Hello dear children, in today's class we will be covering the concepts of atmospheric pressure. So first we discuss what is the atmospheric pressure, how can we demonstrate atmospheric pressure and how this atmospheric pressure can vary with the altitude and the consequences of atmospheric pressure, and after that we will discuss what is a barometer, types of barometer. Children, in that especially we will be discussing only about the simple barometer only. And finally, we discussed the weather forecasting. So, these are the important concepts which we are going to cover in this unit. Children, first, before going to discuss what actually atmospheric pressure, first let us discuss what is the atmosphere. So, for suppose here is Earth, children, and we all know very well that this Earth is surrounded by what, children? Air up to 300 kilometers from its surface. Children, this we know very well, right? So Earth is surrounded by air up to 300 kilometers from its surface. This envelope of air around the Earth only we can call it as a atmosphere. So this everything is what, students? Atmosphere. Simply atmosphere. This is atmosphere. Whatever the air which is there around the Earth, it is up to 300 kilometers. This we can call it the atmosphere. That's fine. Now let us discuss let us recall about pressure. Children, already we discussed what is the pressure, children. Pressure is force acting per unit area. Force acting per unit area. Children, this we all know very well. Yes or no? So pressure is a force acting per unit area and its SI units are Newton per meter square. Now we understood what is the atmosphere and what is the pressure. Then what is the atmospheric pressure, children? So many students, they define like this: the pressure exerted by the atmosphere is called atmospheric pressure. So you cannot say like that. That is that we cannot consider as a what we consider the standard definition. Then how can we define a atmospheric pressure? Now look at here, children. Children, we know that here is a completely air. Okay, now let us assume some air column. Okay, here some air column, right? So let us take some air column. Assume this air column. So here complete, it's nothing but the fluid. Air is nothing but the what, fluid. And we all know very well that fluids can exert thrust on the surface where they are lying. So now this air column exerts some thrust on the earth surface. Now if we can take a unit area surface on the earth, unit area surface, let us consider this a unit area surface, then we can say that the thrust acting by the air column of atmosphere on the unit surface area of earth is called atmospheric pressure. So let me repeat once again, it's very important to understand. The thrust exerted by the air column of the atmosphere on the unit surface area of earth is called atmospheric pressure. Is it clear? Fine. And children, here then what is the weight, that is thrust exerted by the air column on 1 centimeter square area? Means for suppose on earth surface, if you can take here 1 centimeter, here 1 centimeter, example I am telling you. So it is a 1 centimeter and it is a 1 centimeter. So on this, what is the thrust exerted by the atmosphere? So on this, children, 1 kg of thrust will act. 1 kg of thrust will act means 1 kg of thrust will act on the area of surface of 1 centimeter square. Then what is the pressure? Yes, you can use this formula, right? So here pressure is equal to, children, thrust or weight or force, all are similar only. So what is the force acting here? 1 kgf per centimeter square. That is fine. And we know that 1 kgf is equal to 10 newtons. Let us try to convert into SI units. So 1 kgf is equal to what, children? 10 Newton, and 1 centimeter square is equal to 10 power minus 4 meter square. This 10 power minus 4 you can take to the numerator, it will become 10 power 4. So 10 power 4 into 10, it will become 10 power 5. So here pressure is 10 power 5 Newton per meter square. Children, this Newton per meter square only we can call it the 1 Pascal. So the pressure is equal to the 10 power 5 Pascal. 10 power 5 Pascal means this much pressure will act on 1 meter square area. Means on earth surface, children, if you can take a 1 meter width, 1 meter width, 1 meter length, if you can take, that area will be 1 meter square. So on that 1 meter square area, how much pressure acts on that? 10 power 5 Pascal pressure will act. Okay. Now here let us discuss an important point. It's very interesting, I can say that. What is that? Okay, children. So we know that on 1 meter square surface area, 10 power 5 Pascal pressure is acting. Okay. Now on an average person, if you can take human beings, we are. So our average surface area of the body will be 2 meters square. Children, means, for example, if you can take any person, average I am talking. So the surface area of this person will be 2 meters square. Then how much pressure will act? Children, try to understand. On 1 meter square area, 10 power 5 Pascal pressure is acting. Then on our body, means the surface area of our body, on average, its value will be 2 meters square. Then how much pressure will act? 2 times of that. That is here. So pressure of 2 into 10 power 5 Pascal. Children, it is nothing but what? 2 lakh Pascals pressure acts. 2 lakh. Children, very, very, very important. 2 lakh Pascals pressure acts. Then here only we get one doubt. Sir, you are saying the 2 lakh Pascal pressure is acting, but why are we not feeling? I think, right? So this doubt you might have got. Yes, dear children, you are right here. So though this much huge pressure is acting, then why are we not feeling that pressure? The reason is that inside of our body, a blood pressure will be there, which is little bit slightly greater than that of this. Means I can say it's almost equal. So the atmosphere pressure, which is almost equal to the inside our blood pressure. So these both are balanced. As these both pressures are balanced, we are not feeling any kind of atmospheric pressure. So this is the reason why are we not feeling the atmospheric pressure. Is it clear? So this is about what atmospheric pressure. Fine. Okay. Then how can we demonstrate this atmospheric pressure? I mean, okay, we are discussing what is atmospheric pressure, we discussed. But how can we demonstrate? Can we prove that yes, atmospheric pressure is exerting? Yes, children, we can demonstrate in a simple manner. So for this we need one tin can. So generally we will be getting oil, 10 liters of oil can will be there, metal one. So let us that empty one, let us take that. So here, so 2-dimensionally the diagram will be like this, let us say. So this will be okay. Let us take that tin can. 2-dimensional time. If you want to see 3-dimensionally, it will be like this. Okay, na? So the 2-dimensional will be like this. This is okay. 3D type it is okay. So here some hole will be there, right? Yes. So let us take that. Now it is made empty. It's completely empty. So let us take a empty tin can, and in this little bit like 1/3, let us fill with some water. Not completely. So let us take some water. Now put this on fire. Okay. Now let this cap open. Now it is open one, children. It's an open one completely. Now what happened? Yes, we just started giving heat. Then obviously after some time what happens? So here this water starts boiling. Children, whenever the water is boiling, starts boiling, what happened? The liquid state convert into gaseous state, that is a vapor. So here these vapors will be coming here out, and these vapors will pushes the whatever the air which is inside to outside. Here before some air will be there, right? So empty means what, children? Yes, definitely some amount of air will be there. But here as these vapors are coming, these all vapors will push this air outside. Am I clear? Means now after some time inside what will be there? Boiling water and water vapors. No gas here, no air molecule. Inside only two things are there. Water which is being boiled and the water vapors also. Then after some time take a airtight cap and just fix here, completely close it. Now you remove remove the fire. Then you take ice cold water. You can take ice cold water from all directions. Just pour that ice cold water on this can. Then children, what will happen? Surprisingly, you will see, means it will become like this. Let me draw here only. So this will become like this. So something like this, it will become, okay na, something like this. Means what happened? It will be crushed, children, completely will be crushed. If you can take one, we can say, coke tin, and if you can crush, how it will happen? So like that it will become. What is the reason? What is happening? Yes, now I can say that is because of atmospheric pressure. Then you may get one doubt, sir, how can we say that just because of atmospheric pressure? Let me talk here. Children, so inside before, just only water is there, water vapors are there. The moment when you can pour ice cold water from all sides on the tin can, what happened? That vapors are condensed. That vapors are condensed means that water vapors will become water only. So now water vapors will become water. Inside this, above this water, what will be there? Nothing. Vacuum will be there. I mean what? Low pressure region is created. Inside completely low pressure region is created. And here from outside, there is a huge atmospheric pressure will be there. Then what will happen? It acts from all directions, due to which the tin can will get crushed. So this is how we can demonstrate the atmospheric pressure. Is it clear? Fine. Now children, let us see how this atmospheric pressure will vary with the altitude. Children, this is a very important point. So before that, let us recall one important formula here. What is that here? P is equal to H rho G. Children, this we learnt already in a previous class only. What is this actually? This is a pressure exerted by the liquid column. Pressure exerted by the fluid column, you can say that, no problem. Pressure exerted by the fluid column. What is here H? So many of you will think that H for here height. No, it is wrong, children. This is here H is what actually? Depth. Very it's a depth actually. Rho is the density of the fluid. Density of the fluid in which object is placed. G is actually acceleration due to gravity. You may get one doubt, sir. Now why we need to recall this formula to understand the variation of the pressure with altitude? Yes, just wait, you will understand. For suppose children here, so let us take this earth surface. So let us take here is a earth surface. So we know that here, okay, till now we learned about this is a completely envelope of air up to 300 kilometers will be there. Okay now children, let me tell you here one point A, let us take here one point B, let us take here. Now my question is that where the pressure will be more? Where the pressure will be more? So generally many students, they will think that, sir, here, yes, pressure is proportional to the H. And many students, they will think that here, sir, point B height is more than that of the point A, then obviously pressure will be more at a point B, you think. No, it is wrong, children. So here pressure at a point A is greater than that of the pressure at a point B. What is the reason? Let me tell you. I told you that here H for what actually? Depth, not height. So if you can see, this is a depth from top. So let us say it's a HA. And this will what, children? Here is a HB. So since here HA is greater than HB. So pressure at a point A is more than the pressure at a point B. Which means what? As we are going higher altitudes, children, pressure keeps on decreasing. Why pressure decreases? Because the depth decreases. It's one of the points. There are two reasons. So one reason is that as we are going higher, please try to understand, children, it is not a height, rather it is the depth. What is the difference? Height means we'll measure from the surface. Depth means we'll measure from the top. Clear? This is very important to understand. So as we are going higher altitude, children, what is happening? The depth of the atmosphere is decreasing. So when you go for higher altitudes, pressure decreases. That is, atmosphere pressure decreases. Okay, now fine. This is one reason. Okay. Now what is the second reason, children? Yes. Second one is the density. Children, here try to understand here. Let us take here one atmosphere. At first atmosphere, let us say. And here let us take a 100th layer. For suppose let us think that there are 100 layers. Now if you can see, children, on which layer more thrust will act? Obviously, this layer will be compressed more than that of this. As this layer is compressed more than this top layer, which layer has more density? Obviously, the density of first layer is greater than that of the density of last layer. Let us say in this example, 100th layer. Means as we are going higher altitudes, the density of the atmosphere is decreasing. The density is decreasing. Children, from this relation, we also know that pressure is directly proportional to the density. As the density increases, pressure increases. As the density decreases, pressure decreases. So, as we are going higher altitudes, right, and as we are going higher altitudes, density keeps on decreasing. So, atmosphere pressure also decreases. Is it clear? So, these are the two reasons to explain how atmosphere pressure is varying with what is altitude. Children, let us just conclude this here. So as we are going higher altitudes, there are two reasons. First reason is what? As we are going higher altitudes, the depth of the atmosphere is decreasing, and the second one is the density of the atmosphere is decreasing. Because of these two reasons, the atmosphere pressure keeps on decreasing. So because of these two reasons only, these two reasons, at a higher altitudes, when you go to higher altitudes or up mountains, so there will be, nose starts bleeding. Why? At a higher altitude, pressure is less. Inside of our body, pressure will be more. So liquid will flow from higher pressure to lower pressure. So outside at higher altitude, the pressure is less. Inside of our body, pressure is more. So that blood, liquid so-called blood will come out. That is how nose starts bleeding. Even fountain pen also starts leaking at higher altitudes. What could be the reason? Same reason. Because see, when the refill is filled, children, so there it is maintained certain atmosphere pressure here. So when we are writing, why the ink won't come out? Because it is balanced by the atmosphere pressure, equal pressure. But when the same pen, fountain pen, is taken to the higher altitudes, their pressure is less, but inside the ink has more, it is at a more pressure. So obviously that liquid will come out, that is higher pressure to lower pressure. Is it clear? Okay, fine. Now children, the graphical representation means in exam, they will ask us to show the variation of atmospheric pressure with altitude. Variation of atmospheric pressure with the altitude. Children, this graph is very important. Look at here. It is in kilometers. So children, this is how actually we get a graph, which means what? As the height is increasing, means simultaneously depth is decreasing, then what happens? The atmosphere pressure keeps on decreasing. So children, here one important point we need to understand. Atmosphere pressure decreases but not in a linear manner. Why it won't decrease in a linear manner? Because the density of the atmosphere also won't vary, won't decrease in a linear manner. That is why we will get a non-linear graph. But only one thing we need to understand. What is that here? As the height is increasing, depth will be decreasing. Then obviously atmosphere pressure keeps on decreasing. Is it clear? And here an important point. So this curve should start from 76. This is very important examination point of view. And you must mention exactly on what we are taking on x-axis and what are we taking in on y-axis. Children, examination point of view, this graph is very important. So you have to make a note of it. Come on. Children, now we discuss the consequences of atmospheric pressure. We discuss the consequence of atmospheric pressure. Fine children. So these are the four important. Of course, we have many consequences of atmospheric pressure, but examination point of view, these four are important. Now let us see children. So whenever we want to drink, whenever we want to drink anything, any what we can say, some kind of a juice or something. So do you think that it is just because of atmospheric pressure? Children, you know one thing, if there is no atmospheric pressure, we cannot drink actually. Seriously, I am telling you, just look at here. So here, how this atmospheric pressure will help us in order to suck the drink with a straw. Children, actually, so whenever we want to suck the drink actually with the help of straw, actually inside of this straw actually, so air will be there. Try to understand. What will be there? Air will be there. So the moment when we are trying, we think the juice is coming, but pause the situation. While we are sucking that drink with the straw, what is happening? Pause the situation, let us see. So first what will happen, whatever the air is there inside this straw will enter into the mouth first. Children, this is very important. So first what will enter into, inside of that straw some air will be there. That will enter. Children, when the air will come out of the straw, inside what will be there? Vacuum is created. If complete air will come out, complete air is entering into your mouth, then what is here? Inside here, low pressure region is created. Low pressure region is created. Simultaneously, what will happen, this liquid surface is free to atmospheric pressure. So here, huge atmospheric pressure will act. Huge atmospheric pressure will be acting. So here is a low pressure and is a high pressure. Then what will happen? This liquid is forced to enter into this. Forced to enter into the straw. Thereby it will enter into our mouth. It is just because of high atmospheric pressure only. Clear? Fine. Now second one is filling a syringe with a liquid. So same concept, children. Here also, initially what we'll do, this piston will be there. Initially just we'll push it actually. So that what will happen, whatever the air which is there inside of that barrel will come out in the form of air bubble, that we can notice. But the moment when we are pulling the piston, then what will happen, just below, let me tell you, when we are pulling, I'm talking. So just below this barrel, just below this piston, so here low pressure is created. Low pressure is created, and if this liquid is this so-called medicine or whatever it may be, it is exposed to the huge atmospheric pressure. Huge atmospheric pressure. So here is a low pressure is there and a high pressure is there. Then this liquid is forced to enter into it. That is how actually we can fill the syringe with a liquid. And sure, one more thing. So rubber suckers, if you can see nowadays, we are using these rubber suckers as a hangers. And actually this action of these rubber suckers are also based on atmospheric pressure. How they will act? Let us see. So initially, okay, they will be in this form. For this hanger is, it's a hook kind of thing will be what we can say arranged. Now children, the moment when you can force initially, when you can force with our hand, simply what will happen? We'll force this. Then what will happen? Inside whatever the air will be there, it will be forced to come out. So now inside what will be there? Nothing will be there. Nothing means what here? Vacuum. That is a low pressure region. Now what happens? Of course, this rubber, due to that elastic nature, it will try to come out actually. Come out of that wall. But what happens? Don't you think that huge atmospheric pressure is acting? Yes, here. Huge atmospheric pressure is acting, which is useful in holding. Which is useful so that what will happen? This rubber sucker can hold the wall very tightly. Okay, fine. And the fourth one, children. So taking out a oil from a sealed oil can. For example, you have a tin can which we have taken to demonstrate the atmospheric pressure. Now it is completely filled. It is a new one. Then see, I'm trying to show from the top view. So top view of that oil can will be like this. Top view. So for suppose here if you can make a hole, then it is not so easy to take out the oil. Why? Inside complete is a filled, there is no pressure. Then from here, if the the liquid will try to come out, let us say that is the oil will try to come out. But don't think that at the hole simultaneously atmospheric pressure also acting. Yes, so this atmospheric pressure won't allow the oil to come out. For that reason only, what we'll do, exactly opposite, either here or here, we'll make one more hole, either you can make here or here. Then the moment now when you can tilt that can, what happens, here try to come out the, what we can say, oil. And here through this hole, air will enter, which pressurize the liquid to come out from this hole. Try to understand. Means through this hole, means this is free to the atmosphere. So that what will happen? Atmospheric pressure will act here, so that what we can say, oil will try to come out from this hole. So that is the reason why we need to make two holes actually. So similarly, in a chemistry lab, you might have used, what is that here? And even children, so you might be knowing about the what we can say children, you might have heard about the dropper, which you may use in a chemistry lab. Even if you can see the houses where small babies are there, mothers will try to give a medicine, what we can say, syrups with the droppers only. So how they will be, children? So mostly they will be here a kind of rubber one will be there, and which is attached to the either glass one or plastic one. Here small hole will be there. So initially they'll try to press this. Okay, now the moment when you press this, what will happen, children? When you press this rubber one, if you can press, water, the air which is there inside completely will come out. Now you can keep it in any, what we can say, medicine or any liquid. Now the moment when you can leave it, what happens? As inside there is no air, low pressure is there, and whereas here whatever the air is, whatever the liquid is there, which is exposed to the atmospheric pressure. So here on the free surface of the liquid, huge atmospheric pressure is acting, so that this liquid is forced to enter into it. Children, the concept is same. The concept is same. Okay, na? So these are very, very, very important consequence of atmospheric pressure for a examination point of view. Just make a note of it. Okay, children. Now we will be talking about the barometer. Children, what is a barometer? So the device which is used to measure the atmospheric pressure is called barometer. Children, actually as per the books, as per the textbook, so there are three types of barometers. One is simple barometer, next one is 14 barometer, third one is 100 barometer. But examination point of view, I mean as per the syllabus given by the council, children, we don't have 14 barometer and about the 100 barometer also. Means discussion we don't have, only the uses of what you can say 100 barometer which we have, and the explanation of simple barometer which we have. So now first we see simple barometer. We see simple barometer. In 1643, the scientist name called Torricelli, he designed first simple barometer. Now let us see, children. So here this simple barometer, children, it is consisting of millimeters. So children, here, so as it is shown here, simple barometer is consisting of 1 meter length glass tube, means one side is closed, another side it is open, and it is initially, let us fill it completely with the mercury, and after filling, children, just we have to shake it, and even just by closing it thumb, you can do it up and down here. What is the reason here? The reason is that if there are any air bubbles inside, then what will happen? They'll try to come out actually, so that we have only pure mercury inside. Now here let us take one trough. Okay, now so here in this trough, by holding this, what we can say, open end, by closing with the thumb finger, let us invert into it slowly, just keep inside. Okay, now, and here before, it's better if you can take some mercury also, no problem at all. Let us take here some mercury will be there. Okay, now this closed end, that should be completely immersed inside, and slowly you have to remove, make sure that air won't enter. Then after that, what will happen, the mercury from this inside of this glass tube, it will try to come out, and after some time we will notice that the level of the height of the mercury will be stable. The height of the mercury will be stable. So this is how actually it looks finally. And here, children, so here we notice that exactly at a normal atmospheric pressure and temperature, this height of the mercury, which is equal to the 0.76 meters or 76 centimeters or 760 mm. But the thing is that in order to measure the atmospheric pressure, why are we considering the height of the mercury? Height of the mercury in a what we can say glass tube is a question mark to many students. So look at here, children. So the try to understand, very, very important. As we all know that in a horizontal level, if you can take any horizontal level here, if you can take one point A here, one point B, it's very clear that pressure at a point B must be equal to the pressure at point B as per the laws of liquid pressure, Now here we are considering one point inside of this mercury, children, inside of this glass tube at this point A, and here exactly on the surface here, which is exposed to atmosphere B. And don't you think that these two are at the same level? Yes, obviously. Then as per the laws of what you can say liquid pressure, the pressure at a point A must be equal to the pressure at a point B, which means what here? The level of the mercury is balanced. Here you may get one, sir, at a point B means yes, it is exposed to the atmosphere, so that here atmospheric pressure will be acting. Then you may get one doubt, then who is exerting pressure at point A? Yes, this is the liquid column. Liquid column, this mercury height is exerting pressure at a point A, which means what here? The pressure exerted by the atmosphere is balanced by the pressure by the liquid column which is there inside of this glass tube. That is the reason why are we considering the what we can say height of the mercury level in order to measure the pressure. But here we have to mention 76 centimeters of Hg you have to mention here. 76 centimeters of Hg or 760 mm of Hg or 0.76 meters of Hg. It is a mandatory. So is that clear? Why are we considering the height of the mercury in a glass tube? What is a measurement of the atmospheric pressure? So because here the very important thing is that here, so the atmospheric pressure is balanced by the pressure exerted by this liquid column, the so called mercury column which is inside of this glass tube. Clear? Fine. And here one more important point we can notice, children. So then how this mercury level will change inside? I'll tell you, very important, with which only even we are going to discuss about the weather forecasting also. So before that, let us learn one important point here. For example, children, if outside pressure is increasing, let us suppose if outside pressure is increasing, try to understand. If means outside pressure is increasing means what? Pressure at a point B is increasing, so is greater than that of the pressure at a point A. Then what will happen, children? As the outside pressure is more, that is the atmospheric pressure. At a point B, pressure is more means what? This is exposed to the atmosphere. So if atmospheric pressure is more, then what will happen? This, what we can, the atmospheric pressure will be force in this liquid will enter into this. So that what will happen? Obviously, the level of the mercury inside will be increasing. So here, height of the mercury level increases. Okay, fine. Here it can happen like this also. If by suppose any time by chance, if atmospheric pressure decreases, that is what? If the pressure at a point B is less than of the pressure at a point A, then what happens here? Outside pressure is less, inside pressure is more, and we know that liquid will move from point of high pressure to point of low pressure. Now what happened? This liquid will come out of this tube into this trough. Thereby what happened? This height will be decreasing. So here height of the mercury level will be decreasing. Children, these 2 points are very important to understand before going to discuss about the weather forecasting. Is it clear? Fine, children. Now look at here. We will discuss the weather forecasting with the help of a barometer. So here, children, for suppose here, if outside pressure is less, as I told you that, if outside pressure is less, then what will happen? Which means what? The pressure at a point B is less than the pressure at a point A. Then slowly, gradual decrease, you can see that, gradual decrease in mercury level, children. As I told you that, yes, why? Outside pressure is less, inside pressure will be more. So the liquid will be coming out of this tube, so that thereby the gradually the level of the mercury will be decreasing. So which indicates, children, rainfall. So we can say that yes, it is about to rain. For suppose, children, if outside pressure is very much less than of the inside pressure, then what will happen? Sudden decrease. There will be a sudden decrease in mercury level. Here I am not writing, so sudden decrease in a mercury level, which indicates cyclone, or even tsunami also, we can say that. Okay, fine. So these are two cases where outside pressure is decreasing. What happens if outside pressure is more than the inside pressure? Then gradual rise in mercury level, children. So here gradual rise in mercury level means height of the mercury will be increasing slowly. So it indicates dry weather, which indicates dry weather or sunny day. It is or sunny day. Now what happens, children, if outside pressure is very much greater than that of the inside pressure? Then what will happen? The height of the level of the mercury will be increases suddenly, means here sudden rise sudden rise in mercury level, which indicates extremely dry weather, children. Extremely dry weather, extremely dry weather. If there is no change, if the level of the mercury is balanced, then you can say that yes, it is a normal day, it is a casual day, it's a good one actually, we can say that. Okay, so this is how actually we can decide whether it will rain or not, whether cyclone or tsunami or not. So dry weather or a sunny day or extremely dry day, all these things we can decide just based on the level of the mercury which is there inside of the glass tube. Okay, examination point of view, this is very very important. Definitely we can expect the questions. Just make a note of it. Now children, look at here, the very very important. What happens if the barometer is taken into the mine, inside of a mine, if a barometer is taken, how the barometric liquid gets affected? This is very very important. Children, we know that as we are going inside of a, what we can say, mine, children, the pressure keeps on increasing, which means what? Atmospheric pressure will be increasing, means outside pressure will be increasing. As outside pressure increases, what happens? Just recall the quadrant which we discussed. Outside pressure we did it with the PB. So here outside pressure, that is the PB, will be more than the PA. Then obviously what will happen, children? So as the pressure increase outside, the level of mercury obviously increases. So in exam they may ask a question, how this level of the mercury gets affected if it's taken to the mine, and give a reason. Just you can write that yes, level of the mercury increases because as we are going into the mine, the pressure increases. Okay, now fine. And the second one, what happens if it is taken to the high altitude, children? When this simple barometer is taken to the higher altitudes, then how does how this mercury level get affected? Children, as we are going to the high altitude, then the pressure decreases, children. So whenever atmospheric pressure decreases, then what will happen, children? The level of mercury level, so very very important, the mercury level decreases. So it purely depends on the pressure, how the pressure will be changing outside. As we are going into the mine, the pressure is increasing, due to which what happens, the level of mercury rises. So whereas when we are going higher altitudes, the pressure keeps on decreasing, due to which mercury level also decreases. Is it clear? Fine. And here one more important point, children. What happens if any liquid drop is added other than mercury, if any impurity type, children, water drop or any other drop is added into it, what will happen, children? As the vapor pressure of the liquids other than this mercury is very very less, means inside the top of the, what we can say, barometer, that so called space, torricelli vacuum will be there. At that vacuum, what will happen? Less pressure, then this liquid drop will become a vapor, and that vapor exerts pressure inside, children. Just let us recall here. So it's a barometer, means here till here mercury will be there. So here completely vacuum is there, and here some vapors are formed, means this liquid drop will convert into vapor. This vapor start exerting pressure inside of that, that level of the mercury will be there, so and that will try to exert pressure, due to which what will happen? This liquid will try to come out, due to which what happens, children? Obviously the height will be decreasing, means what here? The mercury level will be decreasing. So if any liquid drop is added by mistake, wantonly nobody will add, if it is added, then what happens? How does that level of the mercury get affected? Means yes, the mercury level decreases. Why? Because it will convert into vapor, which exerts pressure on the mercury which is there inside of the tube, so with which it will come out, so that the level of the mercury will fall. Fine. So these are the factors on which actually the level of the mercury might change. Now we discuss two more important points regarding simple barometer only. What is that, children? So we know that here is it's a glass tube. Let us say it is glass tube. So we know that till here that mercury level will be there. So till here, let me just. So this is what actually till here, that height, whatever we just 76 centimeters from here to here. Okay, let it be till the level of that mercury in the trough. Now what happens if this tube of the mercury is tilted slightly, tilted slightly, slightly, it is not that, for example, here it is a tube is there like this, we are not tilting this much, don't expect this much, very very slightly, means for suppose, okay, this is completely mercury, this is completely mercury, for suppose it is tilted like this, it is tilted for suppose, so that it has come like this, little bit it has tilted, let us say that still you can find there won't be any change in the mercury level, means if you can tilt the tube of the simple barometer slightly also, the liquid gets adjusted its height. Okay, this is one important point. This is one important point, means the tilting of what we can say glass tube slightly does not affect the height of the mercury in the simple barometer. Okay, fine. Now one more important point is that for suppose here is till here, let us say it's a mercury in the trough, let us say mercury in the trough, something in the trough, so here it is there like this, this is our what we can say mercury tube, simple barometer tube, let us say this height, we know that, for example, whole height I am talking, whole height from here to here, whatever is left, let us say it is a 0.96 meters, 0.96 meters. Now for suppose this glass tube is immersed little bit, means it is pushed inside, it is pushed inside, let us say, so let us say it is a pushed inside little bit. Now such that its height is 0.94 meters, 0.94 meters, it is little bit pushed. Now we will notice that, children, this mercury level is 76 centimeters, but now also this mercury level will be 76 centimeters only, which means what here, the height of the mercury level does not affect, does not change, even though we can push the tube of the simple barometer little bit inside, still it's a little bit only. So these two things do not affect the height of the mercury in the simple barometer. Is it clear? Fine. Now children, we might get one doubt here. Why we are using mercury as a barometric liquid? Children, what is barometric liquid? The liquid which is used in the simple barometer in order to measure the atmospheric pressure is called barometric liquid. But if you can see, in general, we use mercury only. Here we may get one doubt. So why are we preferring mercury as a barometric liquid? Why can't we use? What happens when water is used as a barometric liquid? No, first part is that why can't we use? So let us see the differences, then you only can understand, yes, you only will feel that yes, we should use mercury as a barometric liquid but not as a water. Okay, fine. So here, for example, here let us see mercury versus water, then you understand. Mercury, children, examination point of view also it's very important. They may ask you, why do you prefer mercury as a barometric liquid, or they may ask you, why can't we use water as a barometric liquid? For the two questions, answers now you are going to get here. So the first point is that here, children, so mercury is a high density, right? So the density of mercury is very high because of its density. How much it is? 13.6 gram per centimeter cube. Whereas here it's mercury is low density. So water has low density, that is 1 gram per centimeter cube. You may get one doubt, sir, what if the density is low? See, because we are constructing a mercury, what we can say barometer with a mercury which has highest density, then we are using 1 meter length glass tube. 1 meter length glass tube. If we can use water as a barometric liquid, we need to have at least 10.5 meters glass tube, children. Try to understand. So the glass tube is like a 10.5 meters. Then can you imagine where can we place that? how can we carry from one place to another place? So it's too difficult, it is not comfortable. Okay, now fine. And second one is that vapor pressure. It has low vapor pressure. It has low vapor pressure. It has low vapor pressure. Whereas water has high vapor pressure. High vapor pressure. So what if it has a high, what if it has low? Children, as mercury has a low vapor pressure, so that what will happen? So here till here mercury will be there, so here pure vacuum will be there. Pure vacuum will be there. So in the place of mercury, if you would use water, then this water would convert into vapor, and this completely space occupied by vapors, and these vapors also exert pressure on the mercury level. So that what will happen? There will be change in the mercury level. Okay, so we won't get a correct readings. Such a mercury is called faulty mercury. Okay, now fine. And the third one is that very important. It is shiny and opaque. It is shiny and opaque. Whereas here it is transparent. It is a transparent. So what is the advantage of having opaque and a shiny? So that what will happen, children, whenever we are measuring the atmospheric what we can say pressure, as the level of the mercury will be changing, so the changes we can notice, because it is opaque, it can be seen very clearly. Whereas what is transparent, it's too difficult to see the changes in the mercury level. So the last one, children, here it does not stick. It does not stick to the glass tube, whereas water will sticks. Water will stick to the glass tube. As water is sticking to the glass tube, what will happen? Once it will raise, let us suppose. So then as it is falling down, whole water won't come. As whole water won't come, there will be a change in the what we can say water level. So with that also we can't take a proper height of the water. I mean the level, whatever we want to measure. Okay, now so these are the reasons why are we preferring mercury as a barometric liquid, and these are the reasons why we do not what we can say use water as a barometric liquid. Okay, na? Is it clear? Fine. The last one is unerred barometer. Now we'll discuss few points we'll discuss about the unerred barometer. Unerred altitude. Fine, children. Now look at here, record the unerred barometer, and for your kind information, children, here. So as I told you that here the working and the construction is not there in the syllabus, so not to worry about it. So come to the unerred barometer, children, here. So how it is better over a simple barometer only can be tested in the exam. So children, here, so this unerred barometer, it has no liquid. Where is in our simple barometer? So liquid is there. So when liquid is there, so definitely for that we need to spend extra money, and it is not comfortable to us also. Okay, fine. And it is light and portable. Yes, so when compared with the simple barometer, it is as it has a liquid, definitely it will be bit heavier only. But whereas when come to the unerred barometer, it is light and portable, so that it can be carried from place to place easily. But whereas simple barometer, when you are taking from one place to another place, as liquid is there, you should be it should be taken with utmost care it is. Okay, fine. And it does not require any prior adjustments. But whereas simple barometer, yes, many things we need to adjust. Here means directly just you can start, so that you can take a readings directly. But whereas simple barometer, you can't take a readings directly. First we'll measure the height. Based on that, we have to use P is equal to H rho G, then we have to calculate the values. But whereas here, direct values can be taken. And look at finally look at the use of the barometer. So barometers are used to measure especially this barometer is used to measure the atmospheric pressure. Okay, na? And for weather forecasting. So whether it is a unerred barometer or a Fortin barometer or a simple barometer, whatever it may be, they are used for weather forecasting. And last use is that it is means barometer, I mean unerred barometer can be used as a altimeter. So finally, what is the purpose of altimeter is enough in an examination point of view. Children, a slightly modified unerred barometer only we can call it as altimeter. Altimeter is not a new one actually. So that is a slight modification we will do in unerred barometer, so that we can get altimeter. Then what is the purpose? Yes, so altimeter is used in aircrafts to measure its altitude, at what height that aircraft is going, so that pilot will come to know that. Okay children, fine. So these are the concepts of atmospheric pressure. Children, especially this unit is mostly conceptual. So you must read the textbook. Here we have many exercise questions which you have to practice. But before going to practice, what we have to do? Yes, we have to read the textbook, children. So again I am telling you, textbook is the best and ultimate source. First read the textbook, then try to do the exercise question, so that what will happen? You will get a command. Okay children, thank you so much. All the very best.